Today the topic of discussion is you have to insert a node, that is insert a node at end of doubly circular linked list. That you have a doubly circular linked list and you have to insert a node at end, that is you have to insert a node in already created doubly circular linked list at last. Fine. So if you see, prior to this we have discussed how to create doubly circular linked list, and in that we have seen what is the menu of doubly circular linked list. After that we have seen how to print element of doubly circular linked list. Then we have seen how to insert node, and in insert node we have seen two cases: how to insert a node at beginning and how to insert a node at middle, that is at any position. Now my third insertion is how to insert a node at end. Let's see, let's start. So you know that insert itself has a menu. Insert itself has a menu. That's when you press 1 you can insert at beginning, when you press 2 you can insert in middle, when you press 3 you can insert in end. My job is to insert in end. I'll press 3, ch will have 3, I'll jump to case 3, and in case 3 I'm calling a insert mid function. I'm calling. Meanwhile, if you want to see the linked list, you have a linked list. So what will actually take place? What will happen? If you want to insert a node at end, suppose this is the last node, suppose this is temp, what will happen? This temp will keep this address of this will keep address of this will keep address of this, and this will keep address of this. So only these changes will take place, and this is very easy coding, and you know the name of everything, you can create it. Fine. Okay. So let's see. So you have a coding of what insert a node at end, and it's a complicated coding, and I'll make after, first of all I'll explain you the complicated coding, and after that I'll make you understand a very simple easy coding. No, fine. So let's start with insert in middle, uh, insert at end. Fine. Insert at end. Let's start insert at end. So sorry, insert at end. So we have created a pointer temp of type node1. What is node1? What is node1? Node1 is when we have created a doubly linked list structure, we have created a structure named node having three part: one data, two pointers. Two pointer, one is next pointer, one is previous pointer. Next will keep the address of next node, previous will keep the address of previous node, and we have created a variable node1. This node1 is a variable of this structure, and then we have type defined it. So by type define means I'm making this structure as a this node1 as a representative of this structure. By using type define, I am making this node1 as representative of this entire structure. So if you will not use type def, then wherever you are using node1, you have to use struct node. You have to write complete struct node. Fine. So in order to simplify the code, what I did, I created variable node1. Fine. Okay. So I have created a variable node1. I have created a variable, fine, and I have created a pointer of node1. Then we have created a node. Why node? Because now again we have to insert a node. And if you want to insert a node, what you will do? You have to create a node. Fine. So you have a current linked list. First of all, what you have to do, you have to create a node. So I've created a node. Finally, what I did, I have created. If you see this coding, I first of all I'm creating a node. So I'm creating a node having name temp, and address is suppose 500. Fine. So suppose now I will ask user to enter the data, because node is created. I'll ask user to enter the data. Suppose user has entered 8. So temp, in address of temp data part, I'll enter 8. Fine. Okay, very good. Now what what I'm doing is that in tail next, in tail next, tail next, this is what I'm talking about. In tail next, put temp. What is temp? 500. So I'll put 500 over here. The moment I put 500 over here, this link will get broken, and this node will start pointing this one. Fine. Okay, because this is going to be the last node, so tail will keep the address of last node. Now temp previous, I'm talking of this, I'm talking of temp previous, will have tail. What is tail? Currently 400, so it will come 400 over here, that is this will start pointing 400. Fine. Okay. Now tail will jump, because what is tail? Tail is always the last node, so tail is equal to temp. What is temp? 500. So tail will come to 500. So tail will come from this place to this node 500. Fine. Okay. And you know the two last line is very important, that tail next will have head. Tail, this node is tail, this is next, will have head. What is head? 100. So what will happen? This node will keep the address of this node, and head previous will have address of tail. Now tail is changed, so head previous will have tail. What is tail now? 500. So instead of 400, 500 will come. So now this will keep the address of this. Fine. So actually what is taking place is that we are changing the what addresses, and we are making the connectivity, nothing else. This is very easy coding, very very easy coding. So if you want to see the figure, so this is actually taking place. Temp is the last node, yes. Temp is keeping the address of tail which is 400. Tail is keeping the address of temp which is what, 500. Fine. This will keep the address of 100, yes. This will keep address of 500, yes. And finally tail will come here. Fine. So at last what will happen? Previous we have 4 nodes, at last we have 5 nodes. Last node was my 7, but here last node is 8, and which has become the tail, and the address of tail is 500. So what I'll say,